So today for my workout, I did a little jog around campus with one of my buddies. And the energy system I was able to kind of apply to this would be aerobic glycolysis or slow glycolysis. So basically, I'm going to use up carbs for this. So I'm going to start with my glucose molecule, which is a 6-carbon molecule. And through hexokinase, I'm going to take a phosphate off an ATP, turning it into ADP, taking that phosphate that came off and slapping it on that glucose, making G6P. I then am just going to flip that around from having the phosphorus on the end to the phosphorus on the beginning of the 6-carbon molecule, making it fructose 6P. The glucose molecule is going to change to fructose, and the phosphate's still in the 6th molecule. And then through another kinase, it's going to be phosphofructokinase, PFK. Kinase meaning deal with another phosphorus, so it's going to take a phosphorus off of ATP and make it ADP. That way you can have 2 ATPs on there, and the molecule you're going to get is F16 bisphosphate, so fructose 1,6 bisphosphate, 1 fructose molecule, and on the 6th carbons, you're going to have a phosphate on each, bis meaning 2 phosphate dealing there. Once you get that, then you're going to split it in half using autolase. Autolase is going to split it into DHAP and then G3P. You're going to take your DHAP and you're going to make that G3P by TDI, which is another isomerase. And it's just going to flip it because you have all the components. You just need to flip it to make it the same arrangement as the G3P. Once you have the DHAP or the G3Ps, you can make those into pyruvates, and then you're going to go and you're going to breathe off a carbon as carbon dioxide, and you're then left with 2 carbon molecule, and that 2 carbon molecule is called acetyl-CoA, and it's going to combine with OAA, which is a 4-carbon molecule, making another 6 carbon molecule called citric acid. That's going to go through the Krebs cycle, making 3 NADH, 1 FADH. All 3 NADHs are going to be able to go through the first pump of the electron transport chain, each one netting 10 hydrogen, 4 from the first, 4 from the second, and then 2 from the last. And then the FADH is going to be able to go through the second pump, producing 4, and then is going to produce 2 in the last pump, 6 hydrogens total. And then 4 hydrogens are going to be able to turn that wheel to make 1 ATP. And then the hydrogens that are kind of pooped out the bottom are able to run through the last electron, be the last electron acceptor, and combine with oxygen, make metabolic water. And that's how I was able to connect that with jogging around campus, because I was going through, that was the energy system I was using, because I'm using my carbs and going through glycolysis with oxygen, making it aerobic.